Hello students, welcome back to Best Academy. Today I am going to discuss new chapter of linear algebra of BS Mathematics students. Chapter 2 is linear transformation. Let's start today's lecture, and first we'll try to understand the definition of linear transformation in subject linear algebra. Let's start. For example, let V and W be vector spaces over field F. We call a transformation T. V to W is called linear transformation from V to W This is the basic definition. Let V and W, the two vector spaces over the field F. We call the linear transformation. Basically, here is we define a function, right? V to W is basically a function, right? So for this, let C belongs to or from vector field and X comma Y belongs to vector space. If it satisfies two conditions. Number one condition is, for example, you're going to apply transformation from V to W, and X and Y is the element over the vector fields, vector space F. So we can say that T of X plus Y is equal to T of X plus T of Y, right? And second is the most important condition, that is scalar type. It means that scalar, if you're going to choose C scalar or vector field, so here will be C into T of X. If it satisfies these two conditions, for example, we choose two elements from vector space F, it's applied the T transformation, T of X plus Y is equal to T of X plus T of Y. And second condition is scalar. If you're going to multiply by T into C of X into C into T of X. So this is the basic definition of linear transformation. Take pause. So now we choose an example and try to understand the linear transformation by an example. I have chosen an example. This is the transformation defined by this, and to show that this T is linear, by using the definition T of X plus Y is equal to T of X and T of Y. Let's start. For example, here are the elements of like this way. So I choose, for example, let X is equal to B1 and B2, and Y equal to, I choose D1 and D2, and I choose a scalar belongs to vector field F, right? So the first definition of linear transformation is T of X plus Y, right? So which is equal to T of X plus T of Y. First we choose this definition, right? Which I have choose the elements from this way. So first we'll write in written left hand side of an expression. So we have X plus Y into operating of T operator. Basically T is here, T is an operator walk, right? So we choose T into, I have the element of X is, that is X, here is B1 comma B2, right? So here is, I have plus D1 comma D2. So if I'm going to apply the transformation, first I will add, I'm not applying transform, first I will add coordinate wise term. So here is B1 plus D1. So here is B2 plus D2, right? So coordinate wise of adding of vectors, B1 is adding to D1 and B2 is adding to D2. So if I'm going to say that here is the first element is multiplied by 2 by definition. So after applying the transformation, so if you notice that the first term is 2 into B1 plus that is D2, right? So and second term is related to, if you have the terms of like B2 plus D2, right? So and second term is B1 D1, right? So this is your left hand side of an expression. Now we choose right hand side of an expression. Here is t of x plus t of y. So we choose t of x plus t of y. So t of x I have. Now I'm choosing right hand side of an expression. If you notice that from left hand side of an expression, I got the values is right like this way. Now we choose t of x. I have the t of x, that is t of x plus t of y. Right, t of x is basically related to b1 comma b2 plus, and second term is related to d1 and d2. So if you are going to apply this way, the transformation is 2b1, right, plus b2, and second term is b1 because by transformation here is the term b1, right? So plus d1 is related to 2d1 plus adding term of d2, right? So and second term is, that is d1 term. And same if you're going to write it by coordinate wise term, notice that here 2b1 and 2 we have the common element, that is b1 plus d1, right? If you're going to add this term by this term, we obtain b2 plus d2, right? So and this term will be like this way, that is d1, b1 and d1. If you notice that from this side of an expression is equal to this side of an expression. For example, I'm going to say that this is equation 1 and this is called equation number 2. So left hand side is equal to right hand side of an expression. Now we should try to justify second property of the linear transformation, that is related to, I'm going to use green marker. For example, second is TC of x is equal to CT of x, right? So now we choose this definition by transformation. So first is T into C of x time. If you notice that we have here, this is the second property. We have the elements of B1 and B2. Now we're using here B1 and B2, right? First is, what is the first property by transformation? If you're going to multiply, the first term is like this way. So here is, and the first term is C, this term like this way. So I can use here multiply by 1 and CB2, right? So here is transformation T, right? If you're going to apply this transformation on the term, we obtain like this way, 2CB1 plus CB2, right? Second term is CB1, right? So if you notice that we obtain this from left side of an expression, and similar case if you obtain multiply by, if you can use, if you can say that C is common, we can take it as a common, and C is basically here is 2B1 plus B2 is B1. So this is an element of TC of x element. If I'm going to apply right hand side of an expression, here if I'm going to say that similar expression will be obtained, we obtain CT of x. So CT of x is already obtained values, so we can look as similar, that is 2B1 plus B2, sorry, here is B2 comma B1. So left hand side is equal to right hand side. So property 2 and 1 satisfy. So we can say that here, if I'm going to, so T is linear. Right? So this is the procedure you can transform, you can prove that any transformation is linear transformation or not. Here I'm going to stop my lectures. If you have any sort of query, any sort of question, you give me a comment. I will discuss in next video. So see you shortly till next video. Bye bye.